Okay, so now we're working on the 4.2 additional vocab support. Here's a sample proof for this one. What they're going about is to end up with side angle side. So this angle B with this angle Y. So we'll go through ours down here. Use the figure at the right. How can you prove that the triangle on the left is congruent to the right, and justify each step? So the first step is, you see the given part has this sentence and it's written here, so then you just put given. Simple enough. Okay, now let's see what that really means. If M is the midpoint of HS, and I'm just going to cover up this part, if M is the midpoint of HS, then that means that this length equals this length, because M is in the middle. Okay? And now if M is the midpoint of GT, then you can mark this one to this one. Now let's see what we have. Okay, on number 2 we have GM congruent to TM, and that's actually what we just marked. So remember we said if there's a word up here, that's probably what you're going to use here if it makes sense, and it does. It's going to be definition of midpoint. Definition of midpoint. And then on the next one, HM equal SM, same thing. Definition of midpoint. So you have given and definition of midpoint for the others. So at this point we have S here and S here. What they're going for here is the angle GMH, which is this angle with this angle. Those are vertical angles, so you could put vertical angles are congruent. Congruent. Or you could put vertical angle theorem. THM is how I'm abbreviating it. So either of those work. And so now that we have the A between the two S's, then this would be SAS postulate. Notice the angles and the triangle have the order of the letters the same. So it kind of makes it easy. So SAS postulate. Any questions? Okay, then on our next one, we've got H as the midpoint, so again we put given. And what that means, if H is the midpoint of GJ, H is the midpoint, makes this one equal to this one. So now at this step, we've got a side here and a side here. GH congruent to JH was from the definition of midpoint. The next one says HI congruent to HI. That's the shared one. And so that'd just be reflexive, because if it's the same thing, and even if it said IH, like it would sometimes, that'd be reflexive. Reflexive. Then we have GI congruent to JI. GI and JI. Those are marked as equal, even though it wasn't in the given part. So this is going to be given on the drawing, or from the drawing, it doesn't matter. It's basically on the drawing, it shows that they're marked. So if that's your third side, then we see we don't have anything about the angles listed, so this would be side, side, side. So SSS postulate. SSS postulate. Any questions? Okay. Now on our next one, here's another picture of SSS with the three sides marked. This one's talking about SAS, and it's the angle between those and the angle between those. So again, this is like your printed notes, which you can use on your tests. Number 1 on this says, what other information do you need to prove it by SAS? What we have is some angles marked, so I'm going to put an A there. We also know this side is a shared side that's in the triangle that's below and above. So the extra information we need is about the RT. RT congruent or equal to FD. RT equal to FD. Since we already know RF equal FR. So the additional information that we had to be told was RT equal to FD, since we already knew about the reflexive side. So that's what's going to make that one SAS. Any questions? Okay, number 2, what other information do you need to say the triangles are congruent by SAS? So remember that A is between the two S's, and so you've got to use the correct angle. Would you use angle A? No, because that'd be SSA. Would you use angle B? Yes, because that's SAS right there, because it's between. And you couldn't use angle C either. So it's got to be angle B corresponding to angle E. So angle B equal angle E, since is the included angle. I'm just going to put the angle symbol instead of writing it out. Remember that the included part is what's between. Included means between. So it's between the two sets of sides we know. We know this side and that side, and we know this side and that side. So B is right in the middle. It's the middle angle. Got it? Okay, so for number 3, this says given DA congruent to MA, so that's what we're going to put here. And here it says AJ congruent to AZ, which is also in the given part. So we just put given. The next part shows you the reason vertical angles are equal. So if it's a vertical angle, it can't be D or J. The vertical angle has to be the middle one, like right there. And so here I'm going to use the order of the letters the same as the proof statement. It says JDA. Well, I've got to say JAD in this case. Angle JAD congruent to angle. J corresponds to the Z, so that's going to be ZAM. And that's because your vertical angles are equal. And then we've got side angle side like that. SAS. It couldn't be SSS because we don't know anything about JD or MZ. Okay, so then our next one, would you use SSS or SAS, or is there not enough information? So on this one, you've got this angle and this side and this shared side. So you can think of that as SSA or ASS. Which is not our postulate, so we've got to say not enough information. I'm just going to put NEI because it's like that, abbreviating. Not enough information, and this is SSA. So whenever it says explain, make sure you do. On this one, we've got an angle here and we've got a side, but we don't know about this one with the other one. So it's not enough information, and we need GC congruent to. Alright, G was the right angle, so we've got to start with D, and so it'd be DY. So that's how you figure it out. You got to think about your corresponding letters like we did on a previous lesson. Then on this one, we've got this set of sides and this set of sides. We don't have the angle between, and we don't have our third side either. So this one's not enough information. We need angle Z equal angle C, or we need XY equal to AB. So all of those were not enough information. Make sure you fill out your reason. Any questions? So if we did this one, it'd be side angle side, because that'd be this, and for the other one it'd be side side side. Okay, so now number 7, given PO is congruent to SO and O is the midpoint of NT. If O is the midpoint of NT, then that means this one equals this one. So since they've already used 1 mark, I'm going to use 2 marks for this. And they basically want you to do your 2-column proof. You've got statements on the left and reasons on the right. Statements on the left and reasons on the right. So you do your T-chart. So the first thing we know is we were given about PO and SO. So for number 1, we put PO congruent to SO, which is given. PO congruent to SO, given. And then for the next one, we put the O as the midpoint. O is the midpoint of NT. That one's also given. Remember, sometimes you may see it as the first one, comma, the second one, and then just put given. But I'm separating them out. So we basically look at the bold word given and put these two things. So I just abbreviated it midpoint, MIDPT, and then that's given. Alright, so what we said earlier was if O is the midpoint of NT, then those are equal. So I'm going to say ON is equal to OT. ON, I'm actually going to say congruent to OT. So just like that other one, we look at the word above, which was midpoint, and we put definition of midpoint. I did MIDPT, just like I did here. So now we have two sets of sides. Are we given anything about PN or TS? No. Are we given anything about angle P or angle N? No. But we know all the time that vertical angles are equal. And then that's going to line up with SAS. So for step 4, we've got to put our angle. So in this case, I'm going to use the same order like the triangle, NOP. So it's angle NOP equal to angle TOS. And that's because vertical angles are congruent. Or you could put your vertical angle theorem. So now that we have two things about sides and the middle angle, we can go ahead and say our proof statement. So triangle NOP congruent to triangle TOS because of SAS. Side angle side. And that's the end of our proof for number 7. Any questions? So we have two given statements, then we have the definition of midpoint, vertical angles are congruent, and side angle side. Okay, on our next one, we're given HI is congruent to HG and that these are perpendicular. So again, we're going to do statements on the left and reasons on the right. And our first one is HI congruent to HG. It's given. HI congruent to HG is given. The next one is about FH perpendicular to GI, which is also given. So what's a little different on this one compared to the others is the other one had midpoint, this one has perpendicular. So you have to go back to what we know about what perpendicular means. So what it means is FHG and angle FHI are right angles. And that's because of definition of perpendicular. Or if you just want to put the upside down T, you can. Definition of perpendicular. Okay, the other thing we're going to need for this one is the side that's right in the middle, because we've got side and angle here, and then here's the side. So we'll put FH equal to FH reflexive. I left off one step on accident. Dang it. Alright, we know those are right angles, definition of perpendicular, and I should have put all right angles are equal. So I'm going to change this to number 5 and put number 4. Angle FHG equal to angle FHI. All right angles are equal. All right angles are equal. Okay, so we've got the thing about the sides, we've got the thing about the angles, and we've got the shared side. So now we can just put this part with side angle side. So for number 6, we've got triangle FHI congruent to triangle FHG, which is side angle side. Any questions about that one? Okay, on the next one it says a carpenter is building a support for a bird feeder. He wants the triangles on either side to be congruent so it's balanced. He measures and finds that this one is equal to this one, and that AC is equal to DF. What would he need to measure to prove them are congruent by SAS? So for SAS, it would have to be this angle equal to this angle. So angle A equal angle D. And then same question for SSS, and it would be if BC equals EF. BC equals EF. Okay, then the last one, an artist is drawing 2 triangles. She draws them so 2 of the sides are 4 and 5 inches long, and there's an angle of 55 degrees. So one way to draw this is to put 4 here and 5 here, and to mark this angle as 55 degrees. Another way to draw it is, okay, and so in that case, that'd be SSA, which is not side angle side. The other way to draw it is if this is 4 and this is 5, this is your 55 degrees. So the answer says, okay, so are her triangles congruent? Maybe. Depends on if 55 degrees is between the sides that are 4 inches and 5 inches. So it depends on if both of them are that way. Okay, that's going to be a good stopping point, and you can work on your Math Excel now.